Hello everyone and welcome to Dr. Anum AI. I am Dr. Anum, a PhD scholar and computer science specialist. On this channel, we decode the complex world of artificial intelligence and explore how technology is reshaping our future. Let's dive into today's video. Introduction: The chaos of the atmosphere. Look at this, a massive storm system swirling over the ocean. It is a chaotic, beautiful, and incredibly complex engine. For decades, we have tried to understand these patterns by looking at them from space and by mapping their movements across the globe. The historical challenge. Our journey to understand the weather began with simple observations. Look at this map from 1872, the early days of the Signal Service. It was a manual, painstaking process of collecting data points and trying to see the future. The birth of data collection. By the mid-20th century, we were launching weather balloons and building the first massive computers to process the results. These early mainframes were the cutting edge, but they were limited. They were the first steps toward a digital understanding of our physical reality. The physics-based bottleneck. This diagram shows how traditional weather modeling works. We take a massive amount of global data and run it through a physics model, a series of complex equations like the ones you see here. The problem? It is incredibly slow. The supercomputer struggle. Even with modern supercomputers, solving these physics equations in real time is a struggle. While the computer is still processing, the physical reality, the storm, is already moving, already changing. We are often 20% finished with the math when the storm has already hit. The data-driven revolution. But as we enter 2026, the dilemma is changing. We no longer just rely on physics models. We are moving toward data-driven AI. Instead of teaching the computer the laws of physics, we show it billions of historical patterns. We teach the AI to recognize the signal within the noise. The neural network advantage. Look at this visualization. A traditional physics model takes 10 days to run a complex simulation. A trained AI neural network can identify the same pattern and predict the outcome in just 60 seconds. This is the aha moment of modern climate science. A sudden insight that resolves a long-standing question. The power of prediction. This speed allows us to stay ahead of the threat. We can predict critical fire risks in forests or the exact path of a hurricane with unprecedented accuracy. By connecting our computing power to the grid and the global sensors, we create a real-time feedback loop. Conclusion: the universal journey. The researcher's dilemma isn't just about weather, it's about the universal journey of human curiosity. We move from the unknown to the known, from chaos to clarity. By leveraging AI, we aren't just watching the storm, we are predicting the future, protecting our cities, and building a more resilient world. What question will spark your research story? I hope you found this video insightful. If you are passionate about AI, healthcare technology, and professional research, make sure to subscribe to Dr. Anum AI and hit the bell icon for more expert insights. Feel free to drop your questions in the comments below. See you in the next one. Stay curious.